Okay, let's start with continue with our revision of Java, and I think I was here. Serialization, yes. So serialization, very important topic. Whenever we have to pass an object over a network, we have to do maybe store it in a better way, store it in less space. We always serialize the object. So let's say how do we serialize. Remember that an interface describes the behavior a class should have, and by having our class implement serializable, it can be serialized by Java Virtual Machine, JVM. Okay, so just by doing this, implementing serializable, we can make sure that it can be serialized by the JVM. Okay. Sorry, my shoulder is a bit hurting today. It doesn't hurt much. It definitely hurts a little bit. I don't know which part. Okay, it's fine. So serializable, yeah. In the example above, we've defined a person class that implements serializable. By implementing serializable, the JVM will know how and what to do when person object needs to be serialized. We'll look at this more later. Okay, so by implementing this serializable, the JVM gets to know, the Java virtual machine gets to know what to do. So we have to do is implement serializable just to let the JVM know what is the behavior of this class. Okay, notice that we did not override a method and implement it for us to be able to serialize a person object, because the serializable is a marker interface. Okay, it's a marker interface. A marker interface provides runtime information to the JVM about the class and does not have any methods associated with it. That's a very cool concept called a marker interface. So I'll note down some of the terms which you should remember from today's class. One of the term, Java basics. One is a marker interface. Okay, so marker interface provides runtime information to the JVM about the class and does not have any methods associated with it. For example, serializable is a marker interface. Okay, okay, let's go. Instruction, move on to the next exercise when you're ready. Okay, go to next. Serializable interface. Previously we learned that to serialize an object we need a class. To implement the serializable interface, notice that although we implemented the interface, we did not need to implement any methods. You may be thinking, if we don't need to implement any methods, why do our class why do we need our class to implement serializable? Okay, that's a great question. In Java, JVM defines a default way for classes that implement serializable to have their objects serialized. Okay, so JVM provides a default way for that. Okay, we don't have to worry about that. And the interface provides runtime information about the objects field type and value for serialization, and it takes care of converting. Okay, everything is done by the JVM. Okay, we don't need to worry about anything. Okay. Ow, sorry. My oof, when my shoulder starts hurting, really dude. The interface provides runtime information about object fields type and value for serializable, and it takes care of converting it into a stream of bytes. Although there is no need to implement any methods for serialization, it is important for implementing class to provide a serial version UID. Okay. Although there is no need to implement any method for serialization, it is important for the implementing class to provide a serial version UID. That's cool. Public static final long serial version UID. What's this? Although there's no need to implement any. Okay, any method. It's important for the implementing class to provide a serial version UID. Okay, so the class which we are making, we should definitely give the serial version UID as private static final long. Okay, I didn't know that. The example above, the serial version UID, a static final long type number, acts as an identifier for JVM to choose the proper class to convert a stream of bytes back into an object. We'll cover this process in depth later. Our serializable class can get a serial version UID in one of the following ways. You can have the JVM define one for you. You can have the JVM define. This is not ideal because depending on JVM, oh wait, you'll get a different value and this may cause deserialization to fail. Okay. You can have your ID generate one for you. This is better than the first option, but you'll need to ensure that your ID has this feature. Okay. You can have your ID generate one for you, that your ID has this feature. You can define the serial version UID explicitly in the class. This is preferred option because you don't need to rely on the JVM or your ID to ensure proper deserialization. Okay, so they're saying it's better you define the serialized version UID. You can have the JVM define one for you. This is not ideal because depending on JVM you have, you will get a different value and this may cause deserialization to fail. Okay, so the same code can have when run on different JVM. No, JVM. What happens when, what's a JVM? Let's search that. What is JVM and what is its role? JVM, Java Virtual Machine, is a software program that runs Java bytecode. It's essentially an interpreter that translates compiled Java code into machine code specific to underlying hardware. Okay, so JVM is responsible, that translates the compiled Java code into the machine code. Okay, it's actually responsible for running platform independence. Written write once, run everywhere. JVM allows Java program to be compiled once and run on any system with a compatible JVM installed. This eliminates the need to recompile the code for different platforms. Okay, so we compile once and run on any system with a compatible JVM. Okay, I just want to ask, I have a serializable class and I have not explicitly defined which UID, serial version UID, serial version UID will def what issues can it because if you don't explicitly define a serial version UID for serializable class, the JVM will automatically generate one based on the class structure. While this might seem convenient, it can lead to potential issues if the class's structure changes. In sorry, incompatible serialization, the government what if you modify the class's structure, add or remove field, the automatically generated serial version UID will change. This can make it incompatible with previously serialized version of the class. When you try to deserialize an old object using new class, it will result in an invalid class exception. Okay, if you modify the class structure, add or remove fields, automatically generated, okay, it will change, make it incompatible. Okay, there are some issues which I am still not very in depth, very much clear about, but I think we can move ahead. You can have your ID generate one for you. Okay, the ID which you are working on, the editor, that can also give you suggestion and generate. This is better than the first option, but you'll need to ensure that your ID has this feature. You can define the serial version explicitly, serial version UID explicitly in the class. This is preferred option because you don't need to rely on JVM or your ID. Although JVM uses the serial version UID to locate the proper class, it does not store the class file as part of the serialization. We need to ensure we load the class file into our program if it's not there already. Okay. With the default process of serializing object and the serial version UID, Java makes serialization easy to implement. Let's practice adding a serial version UID to our serial. Let's begin by creating a class that will serve as a blueprint for creating car objects. Car define public. Let's do that. Okay. I think it's pretty simple. Public class car, private string make, private int year. Okay, let's implement the serializable interface. This has been imported for you in the car to inform JVM that car is serializable. Okay, this is just informer implements serializable. What is this called? This is called a marker interface. Okay, this does not we don't need to override any methods. It just says to the JVM what behavior to give to this class. This is called a marker interface. Okay, let's run this. Done. We need to provide the JVM with a unique identifier when converting a serialized stream of bytes back into an object with a serial version UID. Add a private static final. Okay, private static final long serial version UID with a value of 1. Okay, so now this class will be identified with the value 1, because static final means that it cannot be changed. Final means once declared it will never change. Static means this variable belongs to the class. Okay, and private, everybody knows that it cannot be inherited by the children. They cannot, nobody can access it outside this class. Okay, Okay, we did that. Finally, create a public constructor with two parameters, string and int type name. Okay, let's make a constructor, a parameterized constructor which takes string make int year, and then this dot make equals to make, this dot year equals to year. Okay, define. Okay, we need to add a public explicitly. Done. Okay, let's go next. Serializing objects to a file. Now that we have learned about serializable interface, how to implement it. Okay, let's take a look at how to serialize an object to a file. To do this, we'll need to use the helper class file output stream. How long has the live video been for? Okay, it's 16-17 minutes. Okay, mate, you know what to say. The phone. Okay, let's continue with this. Now that we have learned about the serializable interface and how to implement it, let's take a look at how to serialize an object to a field. To do this, we'll need to use the helper classes file output stream, which will help us to write to a file, and object output stream, which will help us to write a serializable object to an output stream. Let's look at how to do this with some code. Okay, public class person implement serializable private string name, private int age, public static final long serial version uid equals to 1l. Okay, and then public person something something, public static void main throws. Okay. Mhm. Private string name. Sorry, what's this going about? Now that we've learned about the serializable interface and how to implement it, let's take a look at how to serialize an object to a file. To do this, we'll need to use the helper class's file output stream, which will help us write to a file, and the object output stream, which will help us to write a serializable object to an output stream. Okay, there are two things we need to do. File output stream helps us write to a file, and object output stream, which will help us write a serializable object to an output stream. So there are two things, output stream and file. So if we want to write it to a file, we'll use this file output stream. If you want to write it to an output uh, output stream, just an output stream, we'll use object output stream. Okay, what's an output stream? The messages you get on the console when we run the Java program. What's a file? File is just a file where we want to write. So let's look at some code. Okay, public class person implement serializable. So it's a marker, what do we call it, marker interface. It just says to the JVM, hey, person class is serializable, just serialize it when needed. Private string name, private int age, public private static final long serial version UID, that's fine. And then there's a constructor, and there is public static void main throws file not found, IO exception, new. It makes two objects, and then file output stream, and then we have to give the file path in the output stream, and now we can use it. Okay, they made an object output stream also, and in object output stream, okay, okay, I see. So object output stream, we can give system.out as well over here if we want to print it on console. But if we want to print it on the file, then we have to give it file output stream. Okay, so object output stream will be used everywhere. Like, object output stream is the one which helps us serialize object to an output stream. And what kind of output stream? So this file output stream. Okay, write to a file. Okay, so now we understand how to use that. So file output stream, we make an instance, and then we use this instance here. Okay, okay, fine. So object output stream dot write object, and then Michael object output stream dot write object Peter. Okay, that's really nice. Added constructor, define main and initialize two person object Michael and Peter, initialized file output stream, which creates and writes a stream to file name this, initialized object output stream, which will help serialize an object to the specified output stream, which is the specified output stream. So the output stream will be a file output. Use this method which our object output stream has in the main to serialize Michael. And okay, so write object is the method, and after the execution %txt will be okay, we'll see the output. Okay, instruction in the main method, let's create a car object. We need to serialize an object to a file. Okay, do we have a file? Create a car object named Toyota. That's easy. Car equals to new car, and then in the constructor we pass Toyota, and the year is 2021, and then let's call it car A. Car B equals to new car Honda 2020. Okay, they're telling me to change the name of the object. Done. Now let's continue in the main method by creating stream object that we need. Create file output stream and passing the string cars.txt. Okay, we have a class, we have a file. Okay, so file output stream, file output. It's always better to create an object which has the similar name, just the initial letter is of lowercase. Output stream, not string. File output stream equals to new file out stream cars.txt object put stream equals to new put stream file output stream. Constructor cannot be applied to the given types. Okay, but it did give me the first one is correct though, so that cannot be the issue. Okay, really you think that's the issue? You think that's the issue, right? Actually yes. What the fuck? Did I delete it by mistake? Public car string make int here this dot make this dot here. What's the issue now? What the fuck, dude? What the fuck is wrong with this platform now? What the fuck is wrong with this platform now? Come on, dude. No. Ha 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 ha. I need to change my background, I think. Mm, what's that? Okay, that's my leg. I think I could keep it here. How I look fat. Really? What the hell? Yeah, I look fat. I don't know. Some angles I do look fat. This is better. Okay. I see some messages over here. YouTube is not currently receiving. If you believe that this is correct, YouTube health is excellent. I don't know what's it. So they say public car, and that's what I wrote, assholes. That's what I wrote, assholes. And keep my code. Okay, see, now 2 is complete. Now that our helper objects, let's serialize the class. So what's the method? What's the method? Write to object. What is that? What is that? What's the method? Write object. Okay. So just we can use object output stream. Everything is all set. We have defined in the constructor what output stream and all. We just need to write object and it will write at the correct position, and then we need to specify which object do we want to use. So we can put any serializable object and write it. Object output stream dot write object Honda. Done. So write object was the function which helps us serialize these objects. Deserialization. Now that we have serialized, now we want to deserialize, get back our objects. Knowing how to serialize our object is great, but it's become more useful when we can turn serialization object back into Java objects with deserialization, as the name suggests. Deserialization does the opposite of serialization and transforms a stream of bytes into Java objects. Like with serialization, we make use of helper classes, file input stream which help us read a file, and object input stream which help us read a serial. This will be the last topic, and this is going to take 19 minutes. I don't think so. Which helps us read a file. So file input stream first we have to make if we want to read it from the file, and then again the same object input stream will pass in the file input stream, and that will be ready, and we'll use the function read object. Read object will use, but how does it know which to read? Object dot. Okay, so we are explicitly defining person Michael copy equals to person object input stream dot read object. Okay, which will read a file. The previous one I want to see how does the file look like. Can we see it somewhere? Let's ask Gemini. How will the cars.txt file look like? Give me the solution. Okay, it won't be in human readable because it stores the serialized object in binary format. Serialization converts object data into stream of bytes for storage transmission. Okay, we cannot read. However, we can deserialize. Okay, that's understood now. Okay, now we understood. So to deserialize, it's very easy. Same, we have to create an input stream, tell the file name, and then we have to use object input stream. Initially we were using object output stream. Now we use object input stream, and then we use object input stream dot read object, and that's how we deserialize. Okay, Okay, it's important to note that deserialization creates a copy of original object. Yeah, it won't create the original object. This means deserialized object has the same field values as the original object, but it is located in different place in the memory. Also, deserialized object will be in the order that they were serialized in, and we return the explicitly typecast return value back into the object we serialize. Okay. Okay, the order in which we serialized it, deserialization will also give us in the same order. So it's not like we wrote in some file, and yeah, actually we wrote in some file and now we are reading from top to down. Yeah, that also works if you want to understand, but it's not human readable form. It will be byte. JVM ensures it deserializes the object using the correct class file name by comparing serial version UID in the class file with the one in the serialized object. Okay, with the match not found. Okay, let's begin creating the helper object, which use the deserialize an object from file at the main method. Okay, we have to make a file input stream file input stream equals to new file input stream, and then we pass in the file. That is all good. Then we make a object input stream object input stream equals to new object input stream, and then we pass file input stream, and then what do we get? Okay, this is the first task done. Using the helper objects defined previously, let's convert serialized stream back into the Java objects. Okay, and what object, how do we need to store it? So we'll store it like car Toyota, call Toyota copy. Okay, Toyota copy equals to, we have to explicitly say car, and then we do object input stream dot read object. Initially that read object, yes, that was write object, now read object. So read object, and that's it, right? Nothing else. And then similarly car Honda copy equals to car object input stream dot read object. It's a non-static method and cannot be referenced from a static context. What happens if I remove this? Okay, non-static method. That's what I do, right? Everything else is same. What's one thing which is wrong? Did I keep a capital O? What the hell? These are supposed to be the objects, right? Okay. Let's compare original serialized object with this deserialized. Instead they have simple. Create a boolean type named the same object and set the value to be the reference comparison of Toyota and Toyota copy. The new system.out.println output Toyota copy Toyota and is same object to the terminal. Okay. Let's make a boolean is same object and we'll take a car if this dot car equals car. Sorry, just return this. This dot car is a reference to this object and then this car will compare, will return. Okay, fine. And then we use system dot out dot println Toyota copy up, bro? Done.